Hello and welcome back to PharmaWise. Today we are going to discuss about basicity of amines and the effect of substituents on the basicity of amines. Now as you know, amines have the general formula RNH2. It contains nitrogen which contains a lone pair, and this lone pair can be donated, and as per the Lewis theory of acids and bases, lone pair donors are bases, and by that definition our amines which can donate the lone pair on nitrogen becomes Lewis bases. Now imagine an acid like HCl which can accept that lone pair C, and they can form a salt. Like when this hydrogen will accept the lone pair, what it will form is RNH3 plus and Cl minus. So it is going to give us a salt. So when acids react with someone and form a salt, it is going to be a base. So by this means amines are basic in nature. But are they strong bases? No. They are weak bases. And then how we measure the relative strength of weak bases? By the basicity constant or base dissociation constant. So for that we are going to dissolve our amine in water, means aqueous medium, and then what we will get is we will get RNH3 plus and OH minus. So now if we write the base dissociation constant for this equation using law of mass action, what we will get is Kb is equal to concentration of RNH3 plus into concentration of OH minus ions divided by concentration of undissociated amine. Concentration of water we skip because it is constant. So this is the equation for Kb, which we call as base dissociation constant or basicity constant, and this tells us about the strength of bases, amines for that matter. So if I am having two bases, the one with higher Kb value will have the better basicity, or the basic strength will be more. So higher the Kb values, stronger will be the base, right? But generally we don't use Kb values, we go with pKb, which is negative log of Kb, and in that case smaller the pKb values, stronger is the base. So this is how we are going to interpret the relative strength of bases. Let's revise quickly. Amines are basic because they contain a lone pair on nitrogen which can be donated, and as per the Lewis theory, lone pair donors are bases. Then amines are weak bases, and as per the dissociation equation we can write the basicity constant, and which can give us the relative strength of bases. Now the next question arises, what is going to happen when we are going to substitute the amines? So let us study that. Now see, we know that amines are derived from ammonia. They are ammonia derivatives. We replace one of the hydrogen of ammonia by an alkyl group and we get a primary amine. So ammonia is also basic because it can also donate the lone pair. Now as per the definition, lone pair donors are bases. So easier it is for a base to donate the pair of electrons, stronger the base will be. So the factors which make the lone pair more available for donation are going to increase the basicity, and the contrary is also true. Now let us first answer one question which is most frequently asked for 2 marks. Why primary amines are more basic than ammonia? For that we have to consider the inductive effect exerted by alkyl groups. Now we know from the earlier discussion that alkyl groups exert positive inductive effect. Here there is no any alkyl groups present, but when we replace one of the hydrogen with the alkyl groups, because of the positive inductive effect, alkyl group is going to push the electron density towards nitrogen, in turn making the lone pair more available for donation, and easier it is to donate the electrons, stronger will be the base. That is the reason, because of the plus I effect of alkyl groups, primary amines are more basic than ammonia. Now let's further this discussion to secondary amines. Now in secondary amines, two of the hydrogens are replaced by alkyl groups and a lone pair will be there. So now as you can see, there are two alkyl groups who are exerting their plus I effect. So there is even more electron density coming towards nitrogen, and so the lone pair can easily be donated, even more easily. And that is why secondary amines are even more basic than the primary amine. Now let's look at tertiary amines. Now if you look at it, all three hydrogens when replaced with alkyl groups, we get a tertiary amine. Now in this case, you might suppose that there are three alkyl groups, three of them will exert the plus I effect, and yes, it's true, they are going to exert the plus I effect and they are going to release their electrons towards nitrogen, and thereby the electron availability on nitrogen is also very high. But whenever we are talking about electron donation, someone has to approach and accept the electron pair and form a bond, right? So because there are three bulky alkyl groups placed on three sides of the nitrogen, the approach of that atom and the bond formation is not that easy, and that is the reason the basicity of tertiary amines decreases. That is less than even secondary or even primary amines. So tertiary amines are basic, right? But they are stronger bases than ammonia but weaker bases than primary and secondary amines. So this is the reason, if we have to put the ascending order, ammonia has the lowest basicity, followed by tertiary amines, then primary amines, and then secondary amines. So secondary amines are going to be strongest of all. So this is about plus I effect exerting groups like alkyl groups. Now imagine a condition where your amine is attached to, or this carbon which is there is substituted with certain negative inductive effect exerting groups like halogen. Now halogen has the tendency to attract the electrons towards itself. So what it will do, it will attract the electrons towards it and thereby decrease the electron availability on nitrogen. And this is the reason now it is difficult for the nitrogen to give away that electron pair, and hence the basicity decreases, right? So in general what we have discussed is plus I effect exerting groups like alkyl groups, which we call as electron releasing group, they increase the basicity by making the lone pair of nitrogen more available for donation. But the negative inductive effect exerting groups, which we call as electron attracting groups, they pull away the electrons from nitrogen, making the release of electron pair difficult, and hence they decrease the basicity of amines. So this is all about the basicity of amines and effect of substituents on basicity of amines. This question is very important. I hope you have understood the concept. Please study. Let me know if you found this video helpful in the comments below. Thank you so much for watching. Let's meet in the next video. Bye bye.